The diagram below consists of a circle and an equilateral triangle. One vertex of the equilateral triangle lies on the circle, and the opposite side of the equilateral triangle is tangent to the circle. If the area of the circle is 1, what is the area of the triangle? So here is the circle, and the circle has an area of 1. And here is the equilateral triangle, and equilateral means all three of those sides have the same length. And one question you can think of before you start working on the problem is, will our answer be equal to 1, a little bit bigger than 1, or a little bit smaller than 1? Let me shade the area that's in common to both the triangle and the circle. There it is. Now, if you start with that and say they both have that area right there in common, and you look at the rest of the area, and of course the rest of the area for the circle will be these two wedges down here, and the area for the rest of the triangle is up here, I think you'd agree that these areas right here are a little bit bigger than these two areas right here. So all in all, we expect a number which is a little bit less than 1 as an answer for this problem in terms of the area of the equilateral triangle. So let's unshade that now. I'm going to add to this diagram one diameter, and it's going to be the diameter that is from this point right here, which is the tangent point between the equilateral triangle and the circle, down to here, which is that one vertex of the triangle that lies on the circle. If I take the midpoint of that particular diameter, I now have the radius of the circle pinned down. Let me go ahead and label that as R. So for a minute, let's focus on the circle and then come back to the triangle in a minute. One thing you know about the circle is that its area is equal to 1. So since the formula for area is pi r squared, and we know that the area of that circle is equal to 1, you have this formula right here. How do you solve that formula for the radius? Well, the first step is to divide both sides of that equation by pi. When you divide the left-hand side by pi, you get 1 over pi. When you divide the right-hand side by pi, you get r squared. The last step in solving that equation is to take the square root of both sides. When you take the square root of the left-hand side, you get the square root of 1 over pi. And when you take the square root of the right-hand side, you just get r. Now, we don't need to worry about the plus or minus here because the radius, in this case, you can see is a length, so we don't have to worry about the negative. Last thing we can do here is write this as r is equal to 1 over the square root of pi. Now, if the radius of this circle is 1 over the square root of pi, then the diameter of the circle, which is this entire length right there, and I'll call that d, so this is for the diameter, that diameter d will be twice that, and twice the radius is 2 over the square root of pi. So now we have the length from this point down to this point. Now let's leave the circle alone for a while and move to the triangle. So for this particular triangle, because it's an equilateral triangle, these three sides all have the same length. Let's go ahead and label this length right here x. That is the distance from this point of tangency right here across to this vertex. And of course, this length over here is also x because that point of tangency cuts the triangle in half. Now, if this length is x, then this entire length from here to here is 2x, and all of the legs of the triangle have the same length. So I'm going to label that as 2x. And you can now see, because we have a right angle right here, we can use the Pythagorean theorem. And what the Pythagorean theorem will give you is the length of one leg, which is x, it's right here, squared, plus the length of the other leg, and that happens to be the diameter, is equal to the length of the hypotenuse, which in this case is 2x, squared. So let's work with that equation and see if we can find the value of x. And once we have that value of x, we're not far from finding the area of the triangle. So first of all, this is x squared. And this term right here, if you square the numerator, you get 4. If you square the denominator, you get pi. And over here, when you square out the right-hand side, you get 4x squared. The next step in solving this equation is to subtract x squared from both sides of the equation. When you subtract x squared from the left-hand side, you get 4 over pi. When you subtract x squared from the right-hand side, you get 3x squared. The next step to solving this equation is to divide both sides of the equation by 3. When you divide the left-hand side by 3, you get 4 over 3 pi. And when you divide the right-hand side by 3, you get x squared. Finally, the last step is to take the square root of both sides of this equation. You take the square root of the right-hand side, you just get x. When you take the square root of the left-hand side, you get 2 divided by the square root of 3 pi. So we now have the value of x. And the last step is, how do we figure out the area of the triangle? So that'll be over here. The area of the triangle, that will be A is equal to 1/2 base times height. Now, unfortunately, this triangle is upside down, but you can see the base of it here is going to be that much, which will be our 2x, and the height will be this distance right here, which is our diameter. So to put all that together, the area will be 1/2 base, and the base of the triangle is going to be 2x. So we take this value x right here and we double it, and when we double it, we will have 4 divided by the square root of 3 pi. And then for height, what we do is we just take this diameter value here, and this is 2 over the square root of pi. Notice here that this 2 will cancel with this 2. And so what we have at the end, when you multiply those 2 square root of pi's together in the denominator, you just get pi. You get a square root of 3 in the denominator, and you're left with nothing more than a 4 in the numerator. Now, if you wanted to calculate that using a calculator, you would wind up with 0.7351, this is approximate of course, to 4 digits, 0.7351. And this confirms what we said at the beginning of this particular problem, and that is that the area of the triangle will be slightly less than 1, which is the area of the circle.